Okay, so for question number 2, we have the ion HCO2-, and we need to draw its Lewis structure. So first, let's calculate the total number of valence electrons. Hydrogen has 1 valence electron. Carbon has 4. Oxygen has 6. And since we have 2 oxygen atoms, we multiply this by 2. And notice that the overall charge of our ion is -1. So we need to add an additional electron to this count as well. Okay, so when we add all these values up, we get a total of 18 valence electrons. Okay, so now let's try to draw out a skeletal structure where we have carbon as our central atom. And then I'm just going to draw three bonds, or single bonds, to our 3 atoms. And notice that carbon doesn't have a full octet yet, so for one of the oxygens, I'm going to make them double bonded. And now I'll just fill in the remaining electron as in the form of lone pairs. Okay, so let me count out how many electrons I have in this structure. So we have 2 electrons in each bond, and we have 4 bonds. So that is 8. And if we count out all of the electrons on the atoms, we have 8. So, or we have 10. So this brings up our electron count to 18, which is good since this is what we need. So now we have our Lewis structure almost done. I just need to find out all the charges of our atoms. So to calculate formal charge, we use the following equation, where formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So now let's calculate the formal charge on hydrogen. Hydrogen has 1 valence electron, and since there are no lone pairs on hydrogen, we have 0 non-bonding electrons. And there's a single bond that contains 2 bonding electrons, so we do 2 divided by 2. So we get a formal charge of 0. So now let's do the same thing for our carbon atom. Carbon has 4 valence electrons. There are 0 lone pairs and 4 bonds to carbon. So we have 8 bonding electrons divided by 2. So we also have a formal charge of 0. So now let's do the oxygen that's participating in the double bond. Oxygen has 6 valence electrons, and there are 4 non-bonding electrons, so in the form of the lone pairs. And since it's a double bond, we have 4 bonding electrons divided by 2. So the double bonded oxygen also has a formal charge of 0. So lastly, let's calculate the formal charge of the single bonded oxygen. So there are 6 valence electrons and 6 non-bonding electrons. And since there's a single bond, we have 2 bonding electrons divided by 2. So our single bonded oxygen will carry the negative charge. Okay, so now we have our Lewis structure for this ion. And the junior tutor said that in order to find the Lewis structure, we need to determine first the total valence electrons that are participating in the bond formation. So they have 18. The excess electron is represented by the -1 charge. After finding the total valence electrons, pick the least electronegative atom, and that would be the central atom. So carbon was chosen over hydrogen because it's able to form multiple bonds. And then connect the other atom to the central atom by forming a bond which counts as 2 electrons each. Finally, complete the total valence electrons by placing lone pairs on atoms with an incomplete octet. Okay, so this solution is correct.